All right, this is a video to review multiple representations as well as incorporate a few new concepts that we're going to be covering this 6 weeks. So the first problem gives us in words the problem situation, and it says Tommy received a gift card for $200 to Gap for his birthday. He decided to purchase a shirt every month for several months, so there would be more variety in his purchases. He bought a $25 shirt every month. Complete each representation. So we started off with $200, and the first month we didn't subtract any money from it. So 25 times 0. So we ended up with, $200 still. Now after buying one shirt, we should be subtracting $25. So that's going to put us at $175. And after two shirts, we're subtracting $50. Because 25 times 2 is 50. So we should be at $150. And then $200 minus 25 times 3 should put us at $125, and so on. So please remember that the purpose of doing this is so that you can come up with an equation towards the end. The number of shirts is x, so if I take 200 minus 25 and replace this with x, it should equal the remaining balance on the card. So this is your equation that we came up with from the table. And then we actually need to graph it. So we started out with $200, and then after one shirt, we ended up at $175. After two shirts, $150. $125, $100, and then we could, that was the end of our chart, but we could continue to go. So then it would be 75, down to 50, down to 25, and then finally down to 0. It is always important to graph with a straight edge so that you can do estimating and go from edge to edge of the graph. So a few vocabulary terms. Independent variable, a few of these are review, a few of them are new. Independent variable is a variable that isn't affected by any other variable. In other words, it just happens regardless, like the passage of time is a good example of that. The dependent variable is a variable that depends on the value of another. For example, the amount of money you make depends on how many hours you work. So the amount of money you make would be the dependent variable, while the hours worked would have been the independent. The domain is a set of input values that goes into an equation or a function. The range is a set of output values. So when you put something into an equation, what comes out is your range. What goes in is your domain. So a function is a relationship in which every input is paired with exactly one output. And we'll show you what that means in a few minutes. A mapping is a representation that shows how each value in the domain matches up with values of the range. And yes, we'll practice this as well in a minute. So the next part that we're going to be looking at is using that example on the previous page. We want to know what the independent variable is. The independent variable is the number of shirts. And the dependent variable is the amount on the gift card. Because the amount on the gift card depends on how many shirts you've bought. Likewise, the input of the input, or other words, the domain, is how many shirts you bought. So when we looked at our domain, we could have bought 0, 1, 2, 3, 4. That was what was on our chart. But if we continued looking at our graph, we could have bought 4, 5, 6, 7, or 8 shirts as well. We could not have purchased 9 because our gift card didn't have that much money on it. So 0, 1, 2, 3, 4, 5, 6, 7, 8. That was our domain. Now our output was all the values that were left. So after 0 shirts, we had $200. 1 shirt was $175. 2 was $150. And then we went to $125 and $100 and $75 and $50 and $25. And finally we had 0. Okay? So those would be all of your output values or your range. So if I wanted to create a mapping using this information, a mapping is usually done with 2 ovals like this, in which one lists the domain and the other lists the range. So my domain, actually it does not show all of them right now. Let me fix that. 0, 1, 2, 3, 4. It should say 5, 6, 7, 8 as well. And my range was 200, 175, 150, 125, 100, 75, 50, 25, and 0. So when I'm looking at this is my domain over here and my range over here. And I do need to list all of them. And then the way that I show the relationship is by connecting them. You don't have to list them in order. However, it's usually easiest for you and everybody else that's reading it if you do. So I usually try to list mine either in order from least to greatest or greatest to least. So the last thing that we need to look at is this a function? Well, a function is a relationship in which every input is paired with exactly one output. So looking at this, does every input only have one answer? Yes. And so the way we write the function is what we call function notation. This means f of x, which is basically kind of like your y variable, but it just means the function output when I plug in any given x. That's what it means. So is 200 minus 25 whatever x is. So this x, it says this is f of 150, or sorry, f of 7. That means I bought 7 shirts, so I would plug it in. This notation isn't something you're really going to be expected to use much until next year, but it is important that you know that this is our range. This is our output values, which usually we also call y. Let's practice with a few more mappings, because I know that was a lot of information quite quickly. All right, so here's our set. We've got 1, 2, 2, 3, 4, 3, 6, 2, 2, 5. So I'm going to look at my domain first. My domain is all my x values. That's my input. And I'm going to write them down. And notice I have 2 2s. I am not going to repeat. It only happens once. So now my y's, I've got 2, 3, not repeating, 5. So I've got 2, 3, and 5. So we're only looking at the unique values. So when we match them up, I've got 1, 2. So 1 goes to 2, 2, 3, 2 goes to 3, 4, 3, 6, 2, and 2, 5. Okay, so here's the trick. Domains are only allowed to have one arrow coming from it. Ranges can have as many going to it as they want. It does not matter. Okay? The definition of a function was that each domain has only one output value. So this domain has 1. This domain has 2. This domain has 1, and this domain has 1. So this is not a function because of this guy right here. Let's try another one. 1, 2, 3, 4, 5. Those are my inputs because they're my x's. 6, 5, 4, 3, and then another 6. Again, we're keeping them independent, or unique, only the unique values. So 1 goes to 6, 2 goes to 5, 3 goes to 4, 4 goes to 3, and 5 goes to 6. Now remember, we said it was okay for these to have more than one arrow. But it was not okay for these. So is there only one arrow coming out of each and every one of these? Yes. So this is a function. Because again, the definition of a function is a relationship in which each domain only has one y, one range. It doesn't say anything about the ranges only having one. So complete the gift card representations in your booklet, and we will discuss tomorrow.